All right, guys. So yesterday we talked about three factoring strategies: the GCF method, the difference of squares method, and the box method. So we're going to start off by talking about how to factor polynomials with four terms. It's the box method again, but it's a little bit less grueling than the other one. The one where you have three terms is kind of challenging because there's a lot of guessing and checking you have to do. With four terms, there's actually no guessing and checking. You can get the answer right away if you just do it right. Then after that, we've learned all the factoring strategies that we're going to learn for now. So what we're going to do is we're going to put them together to come up with a general strategy for factoring polynomials. So let's begin. I think I'll just go straight to this. I think we're going to go. Interesting. Okay. So we will call this example 1 for today, and we'll title it Factoring Polynomials with Four Terms. So when you want to factor a polynomial with four terms, we're still going to use the box method. How we're going to do it is we're going to put the first term in the top left again. We're going to put the last term in the bottom right again. But now we have two numbers that are in the middle. And so what we're going to do is we're just going to put one of the middle numbers here and one of the middle numbers here. All right. So if I do that, we would have the following. Lower that actually a little bit. And it doesn't really matter which middle number you put in which spot. It'll work either way. All right. So now the cool thing about this situation is that there's no guessing or checking you have to do. You can just get the answer right away because you have all four numbers this time. With the one that had three terms, all we have is the top left and the bottom right. So there's a lot of guesswork. Here we can get them all. And here's how you do it. You're going to find the greatest common factor for each row and each column. And I'll just draw that, and I'll show you what I mean by that in a second. But we're just going to find the greatest common factor in each row and column. So, for instance, let's take a look at these two, negative 21 and 35n cubed. I'm going to find their greatest common factor, and I'm going to put it over here. So what's the biggest thing that goes into 35 and 21? 7. Okay, I agree. And also, how many n's can we take out? 2. So I know that 7n squared has to go there. We're going to do the same thing on the bottom here. 40 and 24. 8. Okay. Now we're going to do the same thing, but going up. So we're going to do each column now. So going this way, how about these two, 35 and 40 in 5? And what? How many n's? Okay. And then this way, the last row. 3. Now with these problems, there's no guessing, but you need to check your answer. It's kind of like sometimes, most of the time it's not a big deal, but you'll see something kind of funny happens here that we need to correct for a little bit. But we've got the right numbers. There's no doubt about it. So and here's how you check your work. So does 7n squared times 5n, does that give me 35n cubed? Does 7n squared times 3 give me a negative 21? Yeah, so we need to change that into a negative 3. And then next, does 8 times 5n make that? So we got to make the 8 negative also. And then last one, does negative 8 times negative 3 give me a positive 24? So there you go. Now, usually the only time you're going to have to fix the signs like that, just so you guys know, is if both of these are positive on this diagonal and these two are negative. Usually it's just going to be obvious if it's negative or not. Like, let's say both of these were negative. If both these were negative, then when you take out your GCF, you would take a negative out. Okay? But in this case, they weren't, so I just took out an 8. But then checking my answer at the end, I found I need to. So I'll say that again. When you're taking out GCF, if they're both negative, take a negative out. If not, don't. But when you have a diagonal here of both negatives, chances are you're going to have to make those negative at the end. All right, so my answer there is going to be 5n minus 3 times 7n squared minus 8. Okay? Bueno? I'll bring up a problem for you guys. Why don't you guys try that one? I'll make it a student practice, so why don't you guys go and do that one right there. I'll give you a second to see how you do. Do that green one there. Okay, so any questions about that? All right, so now we've done all the strategies that we're going to learn, so now what we want to do is put all that together. So let's move along here. I'm going to reproduce the chart that I gave you guys yesterday again. General factoring strategy. So now you guys will notice, like on your homework, I said take out a GCF. And then I said do the difference of squares. Or I said do the box method. Well, that's not usually what happens. All that happens usually is they say factor it. And so you have to make some decisions about what strategy to use. And so the first thing that you're going to do is you always look for a GCF first. I'll put a question mark because it may not be there, but you should check first. Okay? After that, if there are two terms, maybe it's a difference of squares. But once again, I'll put a question mark because just because there's two terms doesn't mean that it is a difference of squares. They have to be both perfect squares with a minus in between them. If there are 3 or 4 terms, then we're going with the box method. Now the box method is, like I said, that's the most tedious one, but that would be the strategy that you would try. All right. Now at that point, you may not be done. You may have to factor a little bit more. Can we keep going? we keep going. So in other words, after you do the box method, you get two binomials, right? Well, maybe one of those binomials is the difference of squares. Okay? So you got to keep factoring until you can't factor anymore. Now, I'm going to give you guys some suggestions here to help save your not having to check some. So, a prime polynomial is a polynomial that cannot be factored. So, just as a heads up for you, some prime polynomials include polynomials. I'm going to tell you what some prime polynomials are. Those are polynomials that cannot be factored, and those are good to know because you don't want to sit there and try to factor it for like 5 minutes and find out it doesn't factor, because they all don't factor. So there's some that we could just look at, oh, I know that one's not going to factor. So I'm going to give you 2 examples of polynomials that you know are not factorable, and you're done with them. Okay. The first one are binomials with a power of 1. What do I mean by that? So like, for instance, let's say you had this 2x minus 5. Well, if there's a 1 there, it's not, you don't need to try the difference of squares on that. It's definitely not going to factor. Something else that's tempting to do difference of squares with is sums of squares. We talked about that yesterday. So for instance, even though something like x squared minus 4 can be factored using difference of squares, x squared plus 4 cannot. So if we come across something like that, we're not going to worry about it. Now notice those are only binomials, right? For trinomials, the only way that you could tell they're not factorable, unfortunately, is the hard way. You just try, and nothing you're doing is working. Now, I try not to give those to you because they're really just a huge waste of time. You go through and try 6 different factoring strategies, and none of them work. And you're not sure, is it not factorable, or did I just not pick the right numbers? Am I missing something? So I try not to give those to you, but just, they do exist. Trinomials that can't be factored are out there. But I'll probably not give you too many of those because it's just kind of a waste of time. Yeah. Yeah, you could say prime. It's called prime is the word. But yeah, that means the same thing. All right, so we're going to do some general strategies for factoring now. So I'm just going to give you a polynomial, and it's going to be our responsibility to factor it completely. I think this is the first one where we need to do that. All right, so go ahead and write that down there. We'll call this example 2 for today. Well, that's interesting. So, Danya, according to that little tree chart, what's the first thing that we do when we're trying to factor? You look for a GCF. Okay, so I'm going to do that. The biggest thing that I can find that goes into 3, 9, 48, and 144 is 3. And they all have at least one x, so I'm going to take out a single x. I'm going to divide 3 by 3, I get 1. 9 divided by 3 is 3. 48 divided by 3 is negative 16. And 144 divided by 3, I want to say it's 48, but maybe someone with a calculator can check me on that. And if I take 1x away from all of those, I would have that. All right, so you always start by looking for a GCF. That doesn't mean there will be one, but you should always look for one, okay? That's the first step. I'm going to check that 144 real quick. Yeah, 40. All right, the next one. Now, this is done. I'm not going to do anything with this guy. He's just going to sit there for the rest of the problem. But all of our work is going to be on the stuff in the parentheses here. So I have 4 terms. So what strategy, I'll ask, not Paolo, not Elizabeth, Timothy. When I have 4 terms, what strategy do I use? Good. So this is the kind of decision making you have to go through as you're solving these problems. You have to think, okay, what do I have? What strategy do I use? And once I've got that answer, I'm going to put it here. So we have x to the 6th goes here. Negative 48 goes here. 3x to the 4th goes here. And 16x squared here. So this is just like the problem that we just did on our last set. All right, so I'm going to factor across. I'm going to factor across. Notice how both of these are negative this time? I'm going to take out a negative 16. Now that might have been hard for you guys to see, but 16 does divide into 48, so I'm going to take out a 16. Going up, I have x squared, and going up this way, I have 3. Now, I am going a little bit quicker, but that's because we've already done that, and I'm not too worried about you keeping up with me on figuring it out, but it's nice to have on your notes and just know I just did the box method just like we did before. I understand you guys would probably need a little more time for that. There it is. All right, so remember, we don't want to forget about this guy. He's still there. He's still along for the ride, so we'll bring him down here. But this piece, we just factored using the box method, and we got x squared plus 3 and x to the 4th minus 16. And that was the box method because we had 4 terms. Now, does that mean on your example problem, your step 2 is going to be a box? No. It depends. If it's 3 terms or 4 terms, yes, but if on your example you have 2 terms only after you do a GCF, well, maybe it's a difference of squares. So you have to think about what strategy will I use.
How do you determine what matches up in the parentheses on the
Now, explain what you mean, what matches up.
the x squared plus 3 and the x to the 4th minus 16. How do you decide which ones go together or not? From the other.
So the x squared and 3 go together because they're both on the top, and then these go together because they're on the side. All right. So I'm running out of space. Am I good to delete this? I'll wait a little bit. I see someone's still writing there. But I'm not done. Because on our tree chart, you know, we do GCF, then we did box method, but the last thing says, can you keep going? Well, it depends. Let's go ahead and look. Sometimes you will be done there, but sometimes you got to keep going. So right now I've got this. Okay. Oh, that's not right. Okay. So just so you guys know, this piece cannot be factored anymore. Like I said, he's just along for the ride. This guy might be able to be factored. Okay? It's got 2 terms. Is that a difference of squares? Why not? Okay, so let me remind you guys what a difference of squares is. A difference of squares is when you have two numbers that both have perfect square roots with a minus between them. So 3, first of all, 3 doesn't have a nice square root, right? We could square root this guy, but we can't square root this and get a nice number out of it, so we're not going to do that. But also, there's a plus here. It can't be, it's a minus. So this is not factorable. We already took the GCF out. It's not a difference of squares. There's nothing else left to try with that one. So that one's prime. It's done. Let's take a look at this guy. 2 terms. Maybe it's a difference of squares. Is that a difference of squares? Yes, it is. So we do need to keep going. So what we do is we're going to write 2 parentheses underneath of it. We take the square root of this one. What's that? That's this guy, yeah, but this guy, what's the square root of x to the 4th? What times itself would give you x to the 4th? So we're going to put an x squared here and an x squared here. And what's the square root of that? 4. You make one a plus, you make one a minus. All right? The others are done. They're prime, so we're just going to bring them down. All right, but are we done? I don't know. All right. We already know this one's done. We already know this one's done. How about this guy? Is that a difference of squares?
No.
It's not. Why not? It's plus, so that's done. We're prime. How about this guy? Got another difference of squares here again. So what's the square root of x squared? And what's the square root of 4? You make one a plus, you make one a minus. You just bring the other ones down. They're done. They're prime. All right. We already know this one's done, this one's done, this one's done, and now we got the last 2 to check. What do you guys think about x plus 2? Yeah. That's not a difference of squares for sure. How about this guy? No. It's a first degree or a binomial with power of 1. I mentioned earlier, those don't factor anymore. So once you get there, it's done. So I'm officially done. This thing has been broken up as much as it possibly can. Okay, so I picked a really big one because I wanted you to see every possible strategy in it. We had all of them. There was a GCF, it had a box, and it had difference of squares quite a few times. But there it is. So you start by looking for a GCF. Then, based on how many numbers there are, if there's 2 numbers, you'll do a difference of squares. If there's 3 or 4, you'll do a box. And after that, can you keep going? And that's it. Is anybody still writing that? All right. So, I don't know how many of these I have. I only have the one. So, we'll see how you guys do with it. I'm not going to treat it like a guided practice. I'm going to let you guys just do what you can with it, and then we'll talk about it at the end. So go ahead and try that. We'll call it that as student practice 2. All right, guys. So we'll call it a day.